Hey, Mark. Good
Okay.
morning.
Good morning.
Hi, Mark. How are you?
I'm well, thanks. How are you doing?
Good to have you. I'm doing great. Just had to jump on the previous Zoom link which we created in order to direct people to this one.
Had there been people dialed in over there?
Just one person.
All right, great. We're glad you caught them. While you were over there, we got the live stream going. I dropped a link in the channel. Just as a note, there is also a chat on the live stream page. So when we get to the Q&A, you'll just want to keep an eye on the chat here on Zoom, but also the chat on the YouTube live stream. And then you don't need to record anything. The live stream will put the recording on our channel as soon as this is over.
Sounds good. Thank you, David.
Of course. And I'll make you host. And unfortunately, I have a conflict in about 15 minutes. I'll have to drop off, but I'll stay until then.
No problem.
So when we get to the Q&A, you'll just want to keep an eye on the chat here. So I think you're all set. Feel free to start whenever you're ready.
Sounds great. Okay. Mark, so we're pleased to have you with us today, Mark. I'm really pleased to have you.
Yeah, I'm glad to be here and join you guys from all the way across the world in California. That's probably the longest distance meetup I've done. So some kind of a record.
Hour difference, was it?
Yeah.
16 hours, I believe. We previously tried to have one of a meetup regarding the interoperability of blockchain, but for some reason it did not happen before. So this is a topic that we long waited for, actually, and I feel that we have the perfect person to introduce us to this topic today.
Well, thanks. Appreciate it. Just to give you a little background on my role and sort of my history with blockchain and this Hyperledger. Up until about 2016 or so, I was involved in distributed transactions in a traditional enterprise sense, having come from BA systems background, working with products like WebLogic and Tuxedo and so on. In about 2016 timeframe, we started looking at the emergence of blockchain and smart contracts and wondering what did that portend for the new world of, sort of B2B, if you will, and transactions that have obviously different connotations in terms of being trusted, being done over a distributed ledger, and so on. And so our team started exploring this technology. We actually joined Hyperledger, I believe in 2007, Oracle joined, and began working on the Hyperledger Fabric-based platform, which we released in 2018. So we've been involved in this for a few years now. And my role is driving the product management of this platform and broader blockchain technologies in Oracle. So I do a lot of work on the product strategy and requirements with our teams. And of course, integration comes in. Integration is a variety of enterprise systems. Oracle and third party comes into that quite a bit. But also do a lot of work with the customers in the field and partners who are building the products, who are also deploying them and integrating them with their enterprises. And so I can share with you a little bit on what we have done from a product capability that helps to address the integration requirements. And I'll talk about sort of the enterprise blockchain landscape, maybe to introduce it a little broader, and what Oracle offers, and then how we handle enterprise integrations within our blockchain platform, which is Hyperledger Fabric, with various enterprise-grade value add. And then we'll drill down into some very specific integrations like e-business suite, which is the most popular ERP system out there, among others, But I also don't want to neglect other types of integrations like analytics and BI, for example, which is very critical in an enterprise. And when you have this data source that's emerging, all of a sudden you have this transaction flowing over an enterprise blockchain, people really want to leverage analytics capabilities as well. That is, part of the kind of standard enterprise toolkit, if you will. And then we get into details of a particular project examples that we did. We actually had a session recently we presented with GE, General Electric, on the intercompany solution, which actually used quite a bit of these technologies together. So you'll see how this is actually applied in the real world kind of a project. And, then we'll have, I'm sure, time for Q&A as well. But feel free to raise questions as we go. Don't wait till the end for Q&A as we go into any of those sections. If there are topics that you want to, drill down into a little bit more, if you have some questions, happy to take them as we go. All right.
Sounds great. Sounds great. Thank you.
All right. So let's get started, I guess. I will first just start with kind of a few broader statements, right? For people who may not be as familiar with enterprise blockchain, how that fits in the world. If you think about multiple companies that share data together, typically it's done today in a point-to-point using a variety of B2B solutions, if you're lucky. Maybe enterprise messaging, or file transfer, file exchange, EDI, or maybe spreadsheets being extracted from various ERP systems and emailed as attachments, which is a lot less formal and subject to all kinds of errors and potential for fraud and other things. And if you think about the companies and how complicated their relationships are today, and dependencies with extended ecosystems, this becomes quite significant problem. It's often very inefficient way of sharing data because the same data needs to be shared with multiple endpoints. Could be quite expensive to set up, and maybe sometimes using intermediaries, particularly in the EDI space, and certainly vulnerable to potential for human errors, potential for fraud and other kinds of risk. So blockchain comes in basically and says, look, we can provide a shared ledger environment that everybody can join and participate in within this ecosystem. And we can provide a single source of truth. So everybody sees the same data at the same time. All of the nodes are updated and data is replicated. There is non-repudiation, meaning that all transactions come in digitally signed, so we know exactly who is responsible for each update, and tie it back to the particular organization. There is consensus based on, pre-existing agreements around consensus and business logic and smart contract and so on. And you have long-term traceability and immutability based on how data is stored in the chain blocks, and ultimately giving you, ability to link transactions historically together, so you can, trace the provenance of a particular product across multiple, organizations, or, history of a particular financial asset or anything like that. And so that's why enterprise blockchain is becoming so popular across many industries and many verticals. Started, of course, in financial services, but at Oracle, we see it being adopted, across many different, and also some of the customers and some of the industries they're in. But, if you think about the enterprise blockchain, some of the things that you would want to then ensure that it can provide, and some of the specific requirements that you have against it, is you want it to be permissioned, right? You don't want extraneous participants. You want only the participants that have been invited to participate, to join. You want the interoperability, so you could have maybe different vendor nodes, particularly joining in, so everybody doesn't have to go with the same vendor. You want the resilience and scalability, of course, in an enterprise environment, 24/7 operation, and 5 nines of availability and all of that, and ability to scale to enterprise scale requirements, whether we're talking about thousands, tens of thousands of transactions per second, large number of participants, number of nodes, hundreds of thousands, and so on. One thing that I'd like to do for people who have history in an enterprise B2B space is to contrast how blockchain technology works compared with more traditional, SO architecture or B2B kind of integration environments, right? On the left-hand side, if you think about traditional enterprise, integrating with other companies. They typically have some kind of a SOA gateway, SOA infrastructure with a B2B gateway rather. The transactions are based on a sequence of business events shared mostly point to point with different individual organizations. Often, B2B gateway basically is driven by batch file transfer. So you have periodic updates. And then the data is reconciled with the backend systems, usually after the fact, right? So there is some kind of reconciliation process done with the application. And you may or may not have an audit trail of all of that because that really depends on the application that's doing all of this. By contrast, if you look at the blockchain and an enterprise blockchain at that, you typically have a sequence of trusted transactions that are coming in from various systems that are processed by smart contracts. Of course, the results of that processing, the read-write sets, if you will, are recorded on the stamp evidence shared ledger. You have multiple authenticated writes rather than point-to-point, so there is basically same data objects updated from multiple organizations as opposed to point-to-point events. You have ability to do real-time updates, right, in a peer-to-peer network. Now, sometimes you might do them truly real-time. Sometimes you might, take periodic updates, badge them together and do them that way. It's up to you, but real-time is certainly a possibility. Smart contracts are used for reconciliation and validation of the data before the ledger is updated. And of course, the transaction history gives you an immutable audit trail right out of the box, right? So, this is why we think that any place where you have a lot of B2B today, you should take a look at enterprise blockchain as a more modern way of connecting organizations. Now, we find that there is kind of four main areas that make blockchain compelling in an enterprise environment, right? What we call algorithmic or fine-grained trust, which is obviously built into the blockchain environment. Traditionally, if you think about how enterprises do business together, it's based on the relationship trust, right? I mean, I know that we have agreement with this company, and generally I believe they're going to do the right thing. But that does not mean that every single transaction and every single person will do the right thing every single time, right? Mistakes happen and other things. And so by being able to do fine-grained algorithmic trust with non-repudiation, tamper of records, process integrity based on smart contracts, etc., you can really improve significantly how you do business. You have the transparency from single source of truth and all of the benefits around optimized decision-making, disruption response, etc. No intermediaries and all of the benefits from that, obviously faster transactions, better customer experience, lower costs, and automation that comes from having this sort of a shared ledger environment that provides ability to have multiple data from multiple silos all coming together and giving you continuous visibility into all of the data, whether it's relative positions in financial sense or inventory or any other kind of data. And that helps to reduce, as I said, risk of human errors and fraud potentially, because you have those pre-agreed rules again that you can use to automate. Now at Oracle, we have this vision sort of for enterprise blockchain focus on business networks, right? So we look at either rapid development of new networks or significantly optimizing existing ones based on the core premises of trusted transactions, single source of truth, and so on. And our strategy in the market sort of is to make the adoption of blockchain easy and quick for enterprises, remove the barriers, prepackage things, and we do that by providing a couple of different options. One is our Oracle blockchain platform, which is a horizontal platform for people who want to build their own solutions, customers, developers, etc. And it's available both in the cloud and on premises. So we have both options available, of course, based on Hyperledger Fabric. And we believe that that's the strongest technology out there in the market for enterprise blockchain, and very rapidly growing and vibrant community that we work with in Hyperledger. And then on top of this platform, we built an enterprise-ready application solution called Intelligent Track and Trace. And that's available as a SaaS application for business users. So it has all the benefits of the blockchain platform, but pre-built application capabilities for track and trace and so on. As I mentioned, we started kind of in 2017, brought out our platform initially as a cloud offering in the summer of 2019. So it's been about 2.5 years. We have probably about 250 plus customers running on it today. 2019 brought the Intelligent Track and Trace application and our enterprise edition of the platform, which was on-premise version. And then earlier this year, we brought a new technology in Oracle database called blockchain tables. And midsummer, we brought out our new cloud platform, new version, what we call Gen 2. And we've added most recently support for a developer tool called Blockchain App Builder. So just a little bit on our history in the space. So as I mentioned, we have different entry points, 4 different entry points to be specific at Oracle for customers to meet their requirements, where was it coming from. So as a blockchain platform cloud, as I mentioned, which is Hyperledger Fabric based, blockchain as a service or PaaS level offering that provides very enterprise focused solutions, highly available, resilient, scalable, supports confidentiality, provides the added API gateway, bidirectional event support, a lot of operation tooling, integration. And so, we'll be talking about this platform mostly today. And the enterprise edition, which is sort of the same platform, basically same code base, but we have taken it out of the cloud environment for people and customers that want to deploy outside of Oracle Cloud. They might have requirements around data residency, data sovereignty that they need, to run locally based on maybe mandates in the country, maybe mandates based on the industries they're in, and so on. But very much the same features and APIs as the cloud, even the same kind of management console, just different provisioning, cloud provisioning versus on-prem provisioning. And then, as I mentioned, this intelligent track and trace, which really integrates a bunch of data from applications inside the Oracle Cloud environment and cloud applications, and then provides a single interface for users to be able to track and trace, monitor various transactions as it happened across these different participants and all of the associated assets and documents and such. And then the blockchain tables, which is a separate offering in the database, just now released in our 21C database, and also will be available in Oracle 19C database coming out in January with 19.10 release update, which is essentially insert-only tables. So we're following kind of append-only logic with cryptographically hash-chained rows. So all of the rows are linked together through cryptographic hashing for essentially verifiability, right, against any kind of tampering. Plus, we provide optional ability for users to add their signatures. And also there is a database count signature, right, database signed digest available, and that provides for a greater degree of, verifiability. And the fact that it's standard in a database gives you all kind of standard, tools you can use, SQL, PL SQL, standard applications, and so on. And this is a good kind of, sort of capabilities for what we would call centralized ledgers, right, to protect against user or admin fraud, any kind of penetration, insider attacks, etc., in the database directly. All right, so on the blockchain platform specifically, as I mentioned, there is over 250 customers that is paying customers, and a bunch of free trials as well. And you see some of the more popular use cases, such as cross-border funds transfer, loyalty programs, KYC for account onboarding, that's across financial services. In supply chain world, provenance, whether it's food or fashion, conflict minerals, and many other things. Maritime shipping and logistics, trade compliance, cross-border trade compliance, those kind of things. A number in public sector as well, healthcare, pharmaceutical, and so on. So I'll show you the examples of the actual production applications that customers have discussed publicly, so we can share them. And you see some examples here, I'll build it out quickly. Financial services, so you see a couple banks in Jordan, actually, Arab Jordan, AJAB, Bank Cross-Border Funds Transfer, non-performing loans marketplaces is in Italy, a KYC solution also in Jordan, Traction, this is, I believe, in Philippines, a retail cards wallet for unbanked, Macraze, this is, I believe, in Lebanon, point of sale, kind of merchant onboarding, Coiners, which is B2B platform for metals manufacturer in India, Diamonds traceability, this is Hyperledger, which you probably have heard about, one of the largest solutions in the space. Used to be on IBM, but has been moving to Oracle. Healthcare, particularly with U.S. Health and Human Services Department, COVID-19 immutable test results. In Italy, intellectual property tracking. This is, again, in fashion, footwear chain, tracking leather sourcing, and this is handmade shoes. So shoemaker traceability and leather sourcing and so on made available across the entire supply chain. Healthcare-driven platform, education. In fact, I think we have a version of this deployed in Saudi Arabia at the Taiba Valley University as well, diploma traceability, one of the customers. Trade services, this is out in Singapore, across Asian countries, shipping, global shipping business network, maritime shipping, food provenance, this is Italian olive oil example. Circular, this is an interesting one around electric vehicle batteries, traceability for Volvo cars, and the extended supply chain that brings not just the battery units, but all of the components that go to make up the batteries, and ensuring that they are all sourced properly, responsibly. Sports loyalty system in sports retailer, Decathlon, and this milk farmers payments calculations as well in Europe. Now, what I wanted to do, I added some tags here to show you a variety of enterprise integration points. So AJB integrates with a core banking system called Banks. Coiners, this is Hindalco in India, integrates with ERP systems. Hyperledger integrates with ERPs. HHS integrates with analytics system. This is health-driven platform, integrates with Oracle Health Insurance. This is Global Shipping Business Networks that Cargosman's built, integrates with ERP, with generic ERP, but also specifically Oracle has a system called Oracle Transportation Manager, OTM, which is kind of like ERP for logistics that it integrates with. Certified Origin integrates with an ERP, and Circle is our analytics as well. So just a little bit of a sense of how this has been used. So, this is sort of at an overview level, right, where we are, what we've done. And now let's talk about our blockchain platform and how we handle enterprise integrations. So as I mentioned, our platform is Hyperledger Fabric based. We've added a bunch of touch points within the Oracle Cloud environment that are necessary for pre-built identity management, event management, containers, off-chain data synchronization, etc. So this is all pre-assembled. You can go into Oracle Cloud, a couple, 2-3 input fields, click create button, and 5-10 minutes later, the entire network is up and running and spun up for you, and you can go ahead and access, and everything is pre-built. You have ability to interoperate with non-Oracle Fabric nodes, so you could have open source or Fabric nodes from IBM, Microsoft and others, because it's all standards-based and interoperable. A lot of plug-and-play integration. So, of course, there is standard Fabric client SDKs. We also support an API gateway that provides extensive REST APIs that can be used to integrate with the platform. And we also integrate with a variety of enterprise adapters from our integration portfolio, Oracle Integration Cloud, that allows us to connect applications, whether they're running on premises or in various cloud environments. Could be Oracle Cloud, Oracle SaaS, third-party SaaS, custom cloud apps, etc. So this is one of the stronger value propositions that we bring to the table. Of course, all those enterprise-grade features I mentioned earlier around high availability, resiliency, scalability. We added membership governance, confidentiality through fine-grained access control inside chain code. So we've enhanced on the basic Hyperledger Fabric capabilities as well, and provided a lot of automation around DevOps and configuration through the REST APIs, Ansible modules. We have Oracle Cloud Infrastructure OCI SDK that allows you to do DevOps as well. So a variety of ways of automating day-to-day management configuration stuff. There's some unique capabilities in the platform. We have been using Berkeley DB to replace CouchDB and LevelDB, and we have SQLite interface on top that allows us to provide essentially the same key value store, but with SQL access on top of it for chain code developers, which is much faster. In analytics integration by streaming the data. So we have this data pump built into the platform that allows us to stream transactions as they come in into Oracle database, what we call rich history schema, rich history database schema. And then that allows us to integrate with a variety of analytics capabilities, and whether it's Oracle or third-party BI tools in the cloud on premises. It's been very, very popular capability. We've done some work to make it easier to onboard a kind of low-tech member organizations who don't need those nodes, but just need to be registered as clients, confidentiality. And then this API gateway that I mentioned earlier for bidirectional integration, which has been very popular because it allows us to expose all of the smart contracts or chain code methods and functions through the REST APIs very easily, and also supports event-driven architecture that allows subscription to events and then callbacks. With, you can specify a callback URL when you subscribe to an event, and then based on that event, we will, call that URL and deliver a payload. And so this is the kind of bidirectional integration that helps to not only drive transactions in blockchain and queries, but also allows a blockchain to then report events into ERP systems and other backend systems. And then the last piece, which I think is very important from an enterprise perspective, is very flexible and interoperable deployment topologies, right? So you could deploy nodes in the cloud, on-premise, third-party cloud, hybrid. We support all of those different combinations. As I mentioned, in addition to the cloud version, we have the on-premise version that we delivered 2019. That's deployable in virtualization platforms like VMware, VirtualBox, same features, same core capabilities, just ability to manage it outside of the cloud environment, and that provides interoperation with third-party Fabric nodes as well. So we've been focusing a lot on trying to make all sorts of different touch points as you go through this entire life cycle easy, right? So easy to deploy and provision, which I talked about, easy to integrate with a variety of back office systems. That's really been very important to be able to get in a POC environment and have ready-made integrations that within a couple of weeks customers can use, partners can use to develop these things and get in and out of a POC in a matter of a few weeks, maybe a month. Pre-built security integrations, identity management, on-chain access control I talked about, ability to manage and monitor it without requiring a PhD in blockchain, which is kind of important. And then easy to add new members and ability to extend this from a POC where you might have 2 or 3 nodes to an environment where you need to be able to interoperate with a variety of additional participants out there, both Oracle-based and non-Oracle, right? So third-party Hyperledger Fabric nodes as well. Now, more recently, we focused on making it easy to not just do the infrastructure and operations, but the application side of it, right? Because obviously a platform needs applications to be successful. So we do this in 2 ways. We have a very rapidly growing ISV community and portfolio of their solutions. And then we have invested in speeding up the custom application build by providing this blockchain app builder that aids in development, testing, deployment of smart contracts, but also can generate chain code automatically from a declarative specification. So, if you remember back when there was a project called Hyperledger Composer, if you're familiar with Hyperledger history, that unfortunately been deprecated now, but Hyperledger Composer provided really nice declarative capabilities to define your assets and so on. Unfortunately, the way that it was generating the runtime wasn't very scalable and ended up not working well. So what we do is we support the declarative specifications and the ability to generate chain code, but we generate native Fabric chain code, right? So you just deploy it as if you wrote it yourself, and you can easily extend it as well. We create the basic CRUD operations, create, read a query, update, and delete. And then you can extend that with any custom chain code on top of that using those operations. So this is a very powerful tool. We have ability to deploy, of course, as I mentioned, in flexible network topologies. So if you imagine an Oracle Cloud environment, you can deploy across all of these different regions, including the data center we have in Jeddah, and a number more planned as well. And you can deploy multiple instances in each region or across the different regions and geography. Inside each region, we have what we call 3 availability domains, which is a metro area. And the data centers are separately deployed like 20 kilometers apart to ensure that they can survive any kind of outage in the metro area. And then you can link those nodes in the network. So this is Oracle Cloud. But then outside, you can also then deploy the Enterprise Edition. You can also have it deployed in your data center, in third-party cloud, or you could deploy open source Fabric nodes, and you can link all of that together. And beyond that, you could also link other clouds, IBM, Azure, SAP, Alibaba, etc., with our nodes as well. So you can create very, diverse topologies that can cater to any requirements and any kind of ecosystem. Now, as I mentioned, we have done a lot of work to enhance kind of on the basic Hyperledger Fabric. So this is kind of the architecture of the components that you get from Fabric open source. And then we've done a lot of work to make it pre-assembled, add the REST proxy, and I'll talk a little bit more about that for integrations, a very powerful administration console, a backplane of supporting services for management, monitoring, high availability, resiliency, rich integration tooling, SQL-based support in chain code, ability to pump the data into rich history database for analytics, automated DevOps, and all of these flexible deployment topologies. But let's talk about the integration specifically here, right? So when we talk about the integration requirements, we focused on different types of integrations and different constituents here, right? So you might have a kind of a low-code developer who wants a REST-driven API, which we provide through the API gateway and ability to do very simple queries, transaction invocation synchronously and asynchronous, and the event support as well with the callback. Of course, the client SDK for more sophisticated developers. Then we provide integration cloud and ability to integrate for folks that are integration architects, enterprise architects. You could do this drag and drop without writing any code, and you can use complex adapters that are available for a variety of Oracle and non-Oracle systems out there, and we'll talk about that in more detail. And then we have the SaaS applications, which are pre-integrated actually out of the box. You don't even need to do anything because it's pre-built integration points. Now, if you look at our REST proxy in particular, we have a variety of APIs available, so you can drill down. We have under the application operations, basic kind of get version just to check that you have connectivity. Transaction-based APIs to send a transaction, and the query chain code. So those are synchronous or asynchronous. You can define in the APIs the roles that you're using, the endorsers you want to use, so different nodes, peer nodes that you want to run this and provide a response, and a bunch of other parameters like timeouts, transient data map, etc. And then we have this event subscription that allows you to list event subscriptions, subscribe to a new event. You can specify when you subscribe different event types. So we support both infrastructure events like block and filtered block and transaction, but also chain code event, which is custom events that you can invoke directly from the chain code business logic. You can specify in the subscription the event name and provide a callback URL. So when that event triggers, then we will invoke this callback URL over mutually authenticated, mutual TLS kind of transaction channel, if you will. So this is how REST proxy works, and we use it quite a bit in all of our enterprise integrations. The other quick point I wanted to highlight was the data pump. This is more around the integration of the data from blockchain into Oracle database and other systems. So we have basically standard Fabric environment here, right? We have a client triggering transaction in the endorser. Then, there is obviously communication to the ordering service to create the block. Ordering service creates a block, sends it to the committer, and we update the state DB and history DB and so on. But in parallel, we have data pump to be able to send the transaction data into Oracle database. We have a schema we call rich history database. And this allows all kinds of really useful things that we'll talk about. But one of them is analytics integration, right? So once you have data in the relational database, much easier to do analytics compared to the struggles people have when they try to do analytics against native Fabric, transaction ledger, which is stored in file blocks. And what people typically end up doing is they have a client that subscribes to events, and then he has a separate stream where those events are sent from the peer node, and then data from events is stored in another database, which puts a lot of extra load on the node here, and is something you have to build at an application level. We provide this integration purely as part of infrastructure, and it's configurable through a few checkboxes. So based on that, we have this notion of a enterprise solution architecture pattern that puts together a blockchain with a number of other services and capabilities into a very, compelling and powerful set of Lego blocks, if you will, right? So on the integration side, we use Oracle Integration Cloud or on-premises our source suite to be able to support a bunch of different adapters that can take application level events that the adapters can receive, and then in this case, let's say e-business suite, and then through our REST connector, invoke our REST APIs. And this is a very common integration pattern, and I'll show you how that works, particularly for e-business suite, but of course it works for any other adapters that we have, and we have a ton of them. for Oracle and non-Oracle systems. And then on the other side, we have this data pump, as I mentioned, pumping data to Oracle database, connecting analytics, and this provides an ability to do dashboards and reportings and so on. So this is very compelling and very popular way of using blockchain in an enterprise, surrounding it with integration, surrounding it with database and analytics and security as well, pre-built. And so we'll talk a little bit about how it works in a real world project when we get to the GE example. But generally, when you think about it, the kind of effort you have to put in to doing a comprehensive enterprise blockchain deployment is significantly accelerated and simplified by using this kind of architecture where you have low-code integrations and orchestrations without having to do a lot of heavy lifting. Dashboards and reports are also something very easy to create without having to write any code. You still have to write some code in smart contracts, or you could use our application builder to generate those automatically. And then typically a front-end application that you would use that needs to be built, mobile or web application or something like that. But this is a kind of infrastructure that enterprise architects really like, because they understand these components. They often already have some of them in place. And so it becomes very easy for them to visualize how this entire system will work. So let's drill down to the next step and talk about specifically the e-business suite, right? E-business suite is a very popular ERP system deployed, provided by Oracle for decades now, and it's deployed both on premises and also sometimes in Oracle Cloud at an IaaS level. And it provides a few different integration points, right? It's a very comprehensive ERP system for financials, for supply chain, all kinds of other things. It has this concept of an integrated SOA gateway with REST support, and the concept of outbound integration and inbound. So let's say we're doing a cloud-based blockchain deployment. We have a network with multiple organizations. So we would typically use the outbound connectivity from a business suite with the EBS adapter in the integration cloud that maps the transactions coming in EBS events into the REST connector, and then uses that to trigger our REST API in the blockchain cloud invoking smart contracts. And the same way, when you subscribe to events, the callbacks could be done back to the REST connector, which can invoke EBS adapter going back, and then blockchain events can trigger inbound integration in EBS. So supporting both outbound and inbound. The other option is you might have some, basic, applications running that actually are able to consume the events, invoke things based on REST API, and also when necessary, make REST calls directly into EBS suite through the SOA gateway and triggers inbound integration. So that's another alternative path that can be used. So how would you put this together, right? What are the key kind of building blocks and steps required? So I'll walk you through very quickly 5 key steps. First, you have to configure the e-business suite itself. Let's say we're doing order management and we want to share purchase orders on blockchain because we want to do some reconciliation maybe between purchase orders, invoices, and let's say shipping information. You then need to set up the EBS connection inside the integration cloud, and then use the EBS adapter in the integration, link it to the REST connector, and create what we call an integration orchestration inside the integration cloud. You then have to build the mappings. Basically, you have payload coming in from a business suite in certain form. You want to create payload for the REST API call, so there is some mapping involved. And then you ultimately activate and test this integration, and you're good to go. So let's kind of walk through that. So the first step, starting in the e-business suite, is you can configure the integration repository in there. And let's say we want to specify sales order outbound service, right? So this is something you can basically click your way through and configure and specify that you want this outbound service for sales orders to be represented through the REST gateway, right? And then you do all the configuration around security and service operations and so on. So that's on the EBS side. Then inside the integration cloud, you would deploy the adapter for Oracle e-business suite. And there is a couple different flavors of the adapter, but you want to use, let's say, trigger and invoke, where essentially we have a connection that's defined to the EBS, to the e-business suite on premises usually, or maybe in the cloud even. And then it invokes certain integrations based on the events coming in from the e-business suite. So here we configure the business events, right? So on the order management suite, we have a business event that we want to configure. And then on the other side, we want to configure a REST connector, which is our invoke part, right? So it basically invokes a REST connector when an event triggers on the EBS side. Then you have to do the mapping, right? So this is a view of where you have essentially on EBS side, you have business event input, and then you have the, business event input, this is on the REST connector side, talking to the blockchain. And here on the EBS side, the payload that you get from this particular event order details. And so you have the mappings here that you can set up to specify for each REST connector payload parameter, which fields to use from the EBS event. All right, and you could make this mapping as easy or as complex as you want. You could, if you want to add transformation coding and other things as well, or just do straightforward mapping one-to-one. So once this is done, then you can go ahead and you can create this orchestration, activate it, and test. And this is kind of what it would look like, you know, with all of the different touch points inside the integration cloud. So hopefully that kind of clarified how you actually achieve one of these integrations, right, with adapter. And then we have, of course, a number of other adapters available for various systems that you could use. So we have, you know, a variety of CRM systems. You can see both Oracle and third party, like Salesforce, supply chain, you know, JD Edwards, e-business suite, SAP, etc. ERP on the financial side, then specific financial adapters, HR-based adapters. And if particular applications that you're using in an enterprise does not have a dedicated adapter here, and this is, of course, a growing list, so you might want to check and see if something has been added. But if you don't have a dedicated adapter, you can then use a technology adapter as well. And so you could integrate file data, database data, etc., and then convert it into, you know, our REST connector. So let's say you can consume a file, break it into individual records, and then convert them into REST calls to the blockchain, and also messaging cloud services, etc. So this is a little bit on how the business suite integration works as an example of a particular ERP integration. A little bit on the analytics. So I mentioned you saw before how we added a data pump in our blockchain platform to push data into the database. So we allow you to basically very easily configure that, right? In our blockchain platform, you can configure each history option, which will give you a pop-up where you specify the database connection. And this could be on-premise database or in a cloud database. And the ones that's configured, then when you go into the channel view, we have basically a channel summary. Right-click on the channel menu, and you can select to configure each history specific to the channel. And there is just a pop-up with a checkbox that says, okay, I want this channel's ledger to be, if you will, synchronized or shared out to this database schema. And then we will basically asynchronously pump the data. And now, you know, you can look at it, for example, in the integration cloud environment, not integration, sorry, analytics cloud environment, to be able to create all kinds of visualizations from the data. You can use it for analytics, as I mentioned. This is one of the most popular use cases. You can also use this for high volume reads if you need to be able to have, you know, a large number of users being able to read the data from the blockchain. It's a little bit cumbersome if you're going directly against the blockchain queries. You might be generating the levels of load that it may not be able to handle, but in a database we can scale to, you know, much higher read volumes. You might want to use it to consolidate blockchain data and external data, maybe from the ERP system itself inside the data warehouse for processing. And finally, if you have multiple blockchain feeds from multiple blockchain networks, and sometimes organizations do have that, consolidate that again through a single database, data warehouse kind of environment. All right, there's different options here. All right, so let me pause here. This has all been kind of on the technology side. Before I get into a particular customer example of how we built all of this for GE, any questions, any thoughts?
I don't see any questions so far.
No? Okay.
Besides someone asking if the slides will be available later, but to answer his question, we will have the recording, and the session will be on YouTube, of course, under Hyperledger.
Yeah.
But please, Mark, go
Okay.
ahead, continue.
So let's talk about the GE example here. And I want to first define what we mean by intercompany for those of you who may not be familiar with sort of a corporate financials. If you imagine a company that typically includes multiple lines of business, and there is a corporate office, there is multiple lines of business or business units, subsidiaries perhaps, and they operate across multiple countries, multiple geographies as well, right? And they have to do business with each other and with the corporate, right? So the subsidiaries might buy from each other across different tax jurisdictions and country borders. There's transactions sometimes between the subsidiaries and the corporate office, right? Corporate office provides certain services, or corporate office may be buying on behalf of the business units from external parties and then, resells, or there may be some accounting transactions for intellectual property and other things. There's all kinds of things that are structured this way. And there's a lot of challenges with this kind of intercompany accounting because, first of all, there is a lot of it, right? So there's been some studies that 3/4 of all B2B transactions around the world are actually done between affiliated parties. Just think about it, right? Parties that are affiliated as subsidiaries or parent-child kind of companies, right? Companies that do a lot of, M&A, mergers, acquisitions, often end up running different business units with their separate ERPs, financial ERPs, right? They bought a company that used to have, SAP, maybe corporates running Oracle e-business suite, but they're not going to migrate them necessarily. Sometimes they do, sometimes they don't. But in many cases, they leave them alone. And so you now have separate financial ERPs, and you need to be able to reconcile whenever you do closings, quarterly closing, end of the year closing, financial reports. There's a bunch of reconciliation work that has to happen, and a lot of people poring over spreadsheets usually in this time. So it's very complex and error-prone and inefficient. Of course, there is a lot of consolidation happening, globalization. So you have this complex multinational value chains, which often attract scrutiny from auditors and regulators to ensure that the intercompany transactions are done properly. And often you have inflexible legacy systems set up if you're lucky. If you're not lucky, you're just using manual spreadsheets and reconciling using spreadsheets. But in larger companies, typically they would have some kind of a legacy system set up. But it's a systems that might not be able to integrate well with diverse ERP systems. There is often manual reconciliations involved. And if you have disputes and those invoices don't get properly reconciled, and they impact revenue recognition, which means the company cannot report that revenue. And also the side effect is that you might have a large number of those transactions, which ultimately result in bank-based payments and foreign transactions, and those require significant bank fees. So the company ends up paying fairly high bank fees to handle intercompany settlement, and they're not able to manage it internally, right? There's sort of externalities here. So GE had all of these issues when we started working with them. GE was doing about 4 million transactions a year intercompany. Just think about that number, 4 million a year, billions and billions of dollars. And they did have a large number of diverse ERPs. Actually, GE has been running across business units over 100 different disparate ERP systems. Many of them don't integrate well. They have a legacy system called Intercompany Billing System, IBS. If you ever worked with GE, you might have heard the term. That was very fragile. They had a lot of disputes that they had difficulty settling. So revenue recognition was certainly a problem. A lot of invoices were being accrued and not recognized as revenue, costing them billions of dollars in actual, reported revenue, and so on. And bank fees, they did have some netting between the companies, but still many of them were not being netted because when you're doing payments across tax jurisdictions and invoice settlement, there is all kinds of regulatory requirements on what you can and cannot net. So we have created this intercompany replacement. I did the POC with them last year to demonstrate the capability to transform the system We essentially based it on the distributed ledger platform, our blockchain platform, to provide near real-time processing. We used event-driven integration with diverse ERPs. You saw ABS integration. That was an example taken right from that project. We've codified a lot of validation rules and business controls and smart contracts. So a lot of business logic embedded in the smart contract, and we supported netting-based settlement. And what this means is that, if you have transactions between unit A and unit B, and let's say, there is a $500 transaction one way, and then there is $200 transactions the other way, the net balance between them is $300. So instead of doing two payments, 500 in one direction, 200 in another direction, you could do a single payment of 300 to settle it, right? And of course, there could be many more than just two transactions offered between the companies, and you end up being able to collapse, dozens and dozens of transactions over a period of a month or a quarter into a single net-based single payment. We linked to a dispute management process using our integration cloud workflow system to provide user collaboration, but with audit support. We built a front-end user experience working with Deloitte as a partner on this project, and integrated our analytics to provide greater process transparency. You can actually see all of the transactions from the blockchain history in the analytics view on a timeline, but then we provided much more sophisticated charts and dashboards that abstracted all of that and gave the accounting and finance users the kind of forecasting charts and dashboards that they really want to see, netting statements, reporting, and all of that stuff. So this is the kind of overall architecture that we put together for them, starting with the concept of connecting multiple diverse ERP systems via the integration cloud that supported internal enrichment and validation services, which are specific GE systems, together with process management and document management. In many cases, when you do an invoice billing, you have to attach supporting documentation, and you have to check before you settle that invoice if the documents are available. So there was document management, process management, governed by the smart contracts running on the blockchain, in this case, across business units. So they all have local copies, each business unit of distributed ledger, each one sets up a separate node. Think about an organization like GE, even though there is a single, enterprise, but underneath there is a whole bunch of business units and independently operating companies, pretty much a perfect use case for blockchain. Then we streamed, of course, distributed ledger transaction into data warehouse and connected them to the analytics, and then created a custom user interface that handled a variety of functions that were available for the end users to manage the rules through intercompany agreements, submit invoices through variety of like spreadsheets and CSVs. In addition to ERP integration, we also supported manual submissions, settlements, disputes, etc., all of those things. So in the core flows of the system, right, we started with data coming in from the ERPs that would go through the enrichment and validation verification phase in the integration cloud, and then invoke smart contracts for a couple of different validation levels. Level 1 validation was around different accounting codes and intercompany agreements, right? If those, now before you can build, you have to have an intercompany agreement saying you're allowed to have these two legal entities across these countries bill using these currencies, subject to this amount maximums and timeframes and codes matching and everything else. So there's a bunch of validations involved. And then level 2 validations were basically what's called in supply chain context two-way or three-way match, where you're matching in a two-way. It's a purchase order and in invoices at the line item level, and three-way match also brings in receipts, ensuring that whatever was purchased was actually received. So if it's a services kind of thing, there's typically a two-way match. If it's a product that was being purchased, something physical, there was then a three-way match because there were receipts involved. And if the match is there, right, if the amounts and the codes and line items match, then we would go ahead and update the netting accounts and then send update events back to the ERP systems. Of course, if any of this failed, then we would invoke process management workflows to deal with failures, and people would be able to be notified through email and then take action and correct stuff. And also you could open disputes based on something, even if it processed into a netting account. if somebody had, oh, wait a second, I don't think this is right, you could open a dispute, and then that would flow through the project management and workflow system to address that as well. And then finally, periodically, you would run a settlement. You would select a bunch of different company codes that you wanted to run a settlement on, and that could be scheduled or on demand. It would generate payment instructions to the treasury that would then translate into either pool of funds-based settlement or actual bank transaction, depending on the countries and business units involved. Payment confirmations would come back and feed into the blockchain as well, right? So this is all, as the middle here, that's all basically blockchain smart contracts. And this would then go and generate events back to update the ERP system. So ERP systems had the current state based on whether the the submission of a purchase order or invoice or receipt succeeded or not. There was first level events, and then there was second level when it was actually scheduled, right? So they had the status. And we also supported manual submission through the web application front end by uploading CSV files, which is something that GE also wanted to have, and they used it with the current system as well. So this is kind of the flow. So let's look at how this was implemented, right? We sort of broke up the system into layers, right? We start with accounting data ingestion from my diverse ERPs. There is enrichment and validation layer to ensure that that we can pick up all of the necessary codes associated with individual business units, project types, project codes, currencies, foreign exchange, all of that. We needed exception management and document management, distributed ledger, of course, data warehousing, analytics, and then the user interface. So we've implemented this using Oracle Cloud. As I said, the ingestion was done using Oracle Integration Cloud adapters. There was additional integration flows that were centralized for enrichment, and then invocation of the blockchain smart contracts. If some of these enrichments and validations or other things failed, the smart contract would check that, and based on the business logic, send an event back. This was event-based call into process management to invoke particular workflow to trigger user corrections. Integrated our document management cloud, what we call content and experience system, sometimes called Oradocs, so that if there are certain documents that are missing, for example, if you're trying to settle invoice between US and Saudi Arabia, and there is tax regulation saying, okay, you need to have the following supporting documents for an invoice, then the document management system was being used to make sure that appropriate documents are submitted. Then we've integrated with Autonomous Data Warehouse, ADW here to pump the data, and then Analytics Cloud, and then use compute instances to support a custom user interface for user interactions. So this is a very good example of end-to-end enterprise integration using blockchain platform in the context of a broader set of enterprise technologies to create a complete solution stack. And you can see that a lot of the systems are pre-integrated, right? So the red lines are essentially pre-integrated connections or application adapters that might need some configuration and things of that sort, but they're basically built in, they don't require any code. And then the blue ones are based on either the REST connectors or SQL calls into the database here, for example. So from the custom UI REST connector into OBP, a REST call to the process management for callback. Here was a SQL call into data warehouse from the application, and so on. And this is a little bit more expanded view here of how the flows actually work. So the blue boxes here represent the GE systems. This is different ERPs across different business units. So like GE Aviation had 2 ERP systems, Vittel and Kitty Hawk. GE Healthcare had 2 different SAP Global GL Prod, and then GE Corporate had CCL Classic ERP system. And also support, as mentioned, manual inflows as well. So the idea was that there would be a business unit specific integration flows that would do some transformations if necessary. There was a centralized integration flow that allowed for calls out to this DRM and NIV enrichment and validation systems to be able to pull additional data into the transaction. And then through the REST connector, call a smart contract on the appropriate node. So if it's coming from aviation ERP, it would call the aviation node. Of course, endorsements policies allowed us to distribute smart contracts across multiple nodes in Fabric. And then depending on the outcome of this, we would, if there is an error or dispute or something, we would then be able to go and call through the process flows for exceptions that would work in our process management system and our order doc system. The data, the transactions were being flown, or synchronized into the ADW for tables and views that provided rich history. From there, accessed by analytics reports, and then accessed also through the compute service with a custom UI application that was built on top of that, accessing both smart contracts directly and accessing reports and dashboards, and also visibility to directly access the data in the database as well. And since we've actually used this kind of a pattern in many other enterprise projects, it's proven to be very common sort of enterprise architecture deployment. If you look at it from a network configuration perspective, what used to happen is you had each business unit, again, corporate, aviation, healthcare, runs the ERP systems and the process management, and then the users would be responsible for linking through all of them, right? So if you have, let's say, corporate selling some services to aviation, or aviation buying a product from healthcare, the users at the ERP system would have to do a lot of manual work. What we've done is instead linked all of that at a blockchain level, right? Brought the, if you will, the orchestration down to an automated smart contract-based implementation in the blockchain nodes, and then link everything up to the blockchain on top of that. So this has radically transformed the concept of how different business units do business, right? And enabled a great deal more automation between them. So if you look at, this, you already seen this chart, right, about sort of the Lego blocks approach, but I'll show you a little bit more details on how the application was implemented here. So, we have created specific integrations and orchestrations for different adapters. So EBS adapter, SAP adapter, and Cloud ERP adapter that was able to trigger smart contracts through the REST connector on purchase order submissions, receipts, invoices, etc. We would then be able to trigger events from the smart contracts going back to the process workflows for any kind of corrections and other issues. The front-end application would be able to interact with smart contracts through the REST APIs and invoke them to run settlement, to query netting balances, and so on, as well as to do manual upload. So users could upload CSV files. We would convert them through the application into the individual REST API calls. They would go back through the integrations here because we needed to have enrichment and other things, and then invoke smart contracts. Of course, the application had the SQL ability to, ability to call SQL for the Oracle database. On the Analytics Cloud, we generated a bunch of reports, and we were able to, in Analytics Cloud, we can actually generate JavaScript that allows you to embed those into applications, right? So that was done here as well. And then on the security side, we've integrated with the different roles and groups and users for the application itself to validate basically role-based security to ensure that authorizations were being checked and met here for users going through the application, which is also important. There's actually a link here to the blog, and I can put that on the chart, actually. Let me just do this. Hold on 1 second. I'll go into the, let me see, where was this? Okay, here we go. I'll copy this. And let me just put it here. There is a blog series that I started, and then the G Enterprise Architect wrote, and it's linked in my blog. I'm linking to his 3-part blog series on exactly how this was implemented, step by step by step. But I'll show you some of the details. So this is the view in the Integration Cloud, where we created a bunch of integration flows for things like submitting invoices, submitting purchase orders, and so on, capturing events coming back in from a blockchain to send to EBS and so on. So this is integration specifically built in the Integration Cloud, right, using off-the-shelf adapters. And this is kind of the, if you drill down into a particular integration, this is what it would look like. In this case, going in and invoking the REST connector. In other cases here, we would have an intermediate system. This was invocation. During the integration flow to the service called Eve that GE had was a custom application that returned valid accounting codes for different business units. And that was integrated into the payload that was then ultimately used in the REST code. So this was kind of important to be able to pick up this additional data that was in systems beyond the ERPs themselves. Then in the blockchain environment, this is a view of the blockchain network. We have 3 separate nodes: corporate, aviation, and healthcare. The green circles represent the peer nodes that host the ledger copies, as well as provide the smart contract executions. You could set this up in 1 or more channels where you essentially can maintain confidentiality if you needed to. So we have set up a few different channels across different organizations. Some were shared channels, some were dedicated channels, and you see different peer nodes belonging to different channels here. This is the topology view in Oracle Blockchain Platform admin console. And then you could drill down into individual channel ledger. So this is different channels. We'll drill down on one, and you can see the ledger browser giving you the history of the blocks. And then you can drill down on the block and see the individual transactions and payloads of the data, and so on. And of course, this was an admin interface for troubleshooting and so on. There was something separate that was built specifically for end users. We have a lot of events that we were using. So event subscription mechanism turned out to be very useful here. You can see here, this is just a listing of all of the different events we're subscribing to. Hold on 1 second. I have the things that I want to move this out of the way. Bear with me. Okay. So we're subscribing to all kinds of different events here. We are then going to go and, based on the events, trigger process workflows in the integration cloud, right? And so this is a very powerful capability to handle disputes. Before that, disputes were done through email, and people wouldn't have any kind of accountability, right? You know, somebody doesn't respond, forgets, etc., or, you know, they may not be able to have a history. If an auditor comes in and says, okay, this transaction looks suspicious and looks like there was a dispute, can you show me the history and how it was resolved? Very difficult to go and find that history in email across multiple parties and multiple business units. Whereas here, everything was kept, all communication was done through the process management workflows with updates. And ultimately, they had the ability to, you know, send email to the users. The users could take actions. There were templates in the email they could click, and that would go back to a variety of process workflows, as well as to this front-end application, where they would be able to then submit updated data through the integration cloud and triggers that update going back in. So a great deal of control and auditing over the disputes. I mentioned the rich history database. So this is the configuration view. So there is this little action menu that you can pull down the rich history configuration and update. And then you go into a particular channel and you have a checkbox that says, okay, I want this channel to be synchronized to this particular database connection. And then what happens is you now start getting tables in the database. And this is a SQL developer connecting into Oracle database, showing you what it looks like inside the database when you have the transaction information and so on. And the way that we store the transaction payload is typically in a JSON field in the database. So then what we did was we actually unpacked JSON into a relational structure. And you can see a little bit of the work here of how different JSON structures were being unpacked to create a fully relational structures in the views, right? And then those views were being consumed and used by the analytics service to create, for example, provide transaction history, to provide more sophisticated reporting. In this case, we're doing a counterparty report by currency. So we're showing to and from business units and the different amounts based on the currency of settlement and transaction history. And you could do many other things based on that, right? Once you have data in the database and you have powerful analytics tools and BI tools. Security integration was also included because this is kind of important, right? In an enterprise context, role-based security. So we used our identity cloud, and it was federated to the GE on-site identity providers. So the federation was set up here. You can see in the identity cloud. to talk to the GE identity provider. And then based on that, we had users that were being authenticated. We had groups defined, and you can see the different groups here based on the access roles, and then ultimately specific roles that those groups were being assigned to, based on whether they had admin roles, client roles, REST API access, ability to look at the reports in the analytics cloud. So all of the standard enterprise role by security, which is kind of important. So just to summarize here, right? So we brought together as part of this particular project, I called it IDEAL, intercompany distributed accounting ledger. All of the different services, right? The integration service, the blockchain, autonomous database, analytics, identity management. And together they really provide greater value. GE has a term, what they call wing-to-wing architecture, right? Let's think about an airplane and everything, right? All the multiple systems are integrated. And basically you have to think about it from end of one wing to end of another wing, and how all of this flows through the integration. So we kind of picked up this term, wing-to-wing architecture. Being able to put together these Lego blocks really helps with rapid development of very complicated applications, sometimes complex flows and so on, because you're using pretty much pre-built connectors, adapters, standard APIs, well-defined, and it's easy to extend it, right? It's not just it's quick to build. It makes it very easy to then extend it to additional ERP systems, additional business units, additional countries, and so on. And so if you think about it, it has these multiple layers, right? From the accounting data ingestion and transformation to smart contracts with business logic on a blockchain. And then you have the analytics services, and you have, the end user services for the UI and so on. And it's really sort of a microservices-based functionality that's structured across those independent layers, which, is a very modern style architecture. It enables a lot of, as I said, a flexibility, obviously, from IT perspective, because you have different topologies that you can support. You could have business units with their own nodes. You could have different business units maybe sharing nodes. You could have an environment where maybe you are divesting of a particular subsidiary or a business unit, and you want to spin them up onto a completely separate infrastructure. You can do that easily without any application changes, right? You might have a separate instance of the integration cloud, separate blockchain node, etc. And so you can, speed up kind of the divestiture process. Or you are merging, you're acquiring somebody, you're bringing them in. Again, very easy to set up an infrastructure using the current environment, linking to the environment into that system. Of course, it's distributed. You have the high availability, resiliency. It's a managed cloud service, which is how GE preferred it. We can also do this on premises as well. Very cost effective, and ability to evolve it easily, right? To have all kinds of additional processes, additional smart contracts, dashboards. For downstream integrations, we link with the treasury systems, but we could also link directly with, bank payment APIs and many other systems as well, necessary for this. This is kind of a summary architecture view and the benefits of this, not only, for GE, but in general. So I'll pause here and, just summarize, and we'll open up for more questions here. In summary, I wanted to talk a little bit about other similar types of use cases that are actually well aligned with Oracle applications and enterprise systems, right? So when you think about the integrations, you want to think about the kind of systems you might be integrating with. And so I put together here a summary for e-business financials integration, supply chain management, which can be done through a business suite or JD Edwards, transportation management, which is typically used in logistics, PeopleSoft, which is used for financial, but also HR or Fusion HCM, and for Siebel, which is a system used for CX, right, customer experience in general. So in the financials world, the intercompany reconciliation settlement is what we saw before with GE, but then you also have examples for things like invoice factoring and integration with accounts payable, accounts receivable systems. That's another use case that we've seen that would require similar kind of integrations for flowing invoices back and forth. For supply chain management, there is all kinds of things, right? Integration with shipping data for 3PL, provenance tracking. Maybe it's some parts in automotive, maybe it's CPG, maybe it's other kind of, provenance tracking of various systems. Another useful thing, use case for blockchain that integrates with the standard ERP systems is vendor onboarding and validation. So often there is very complex due diligence processes and document exchanges involved before a new vendor is actually added in your procurement system. And a lot of that can be done and accelerated using blockchain. Transportation management, right, which is kind of an ERP system for logistics. So ability to track the data. Typically you have in the logistics system, you have core, transportation hubs. You have a variety of freight forwarders, carriers, distributors. You have people who provide data. We have one customer that's, I think, based out in Singapore that has been implementing OTM. They do a lot of raw commodities, grain, agriculture commodities, distribution and shipping. And they found that they needed to incorporate over 200 additional data points from external sources into their system. And some of it is through transportation brokers, some of it from carriers, and so on. So a lot of this data is really difficult to get. And just think if those all were available on the blockchain. Well, we actually have one example of where the data is being shared through this global shipping business network, GSBN, that Oracle's been working with a partner of ours called CargoSmart to deploy across a variety of container carriers and ports and terminal operators and so on. The other good use case that integrates with OTM is tracking shipment status and conditions, usually by leveraging IoT sensors and reporting the data from temperature controls, as environmental controls, geolocation, all sorts of IoT sensors, and reporting the data, storing it in blockchain, so it's tamper-proof. Maybe not storing every single reading, maybe storing just exceptions. If, let's say, temperature controls are set to certain range, and if it's being exceeded, then you report it on a blockchain and so on. Some use cases around HR integrations, right? So verification of education credentials. When you have a new person joining the organization, you have to do a lot of verification, due diligence, typically through third-party services. Well, some people are now doing that through the blockchain, right? And employee onboarding security clearance process, that's another big one. Again, you typically have to reach out to a lot of external organizations. You might need to reach out even, if you have a lot of employees that are immigrants, certainly, expats, etc. in Saudi Arabia, there is a process that often involves, consulates, embassies, police departments, all kinds of organizations. So having the ability to share the data persistent on blockchain is very useful. And then if we're talking about customer experience, a really great use case is loyalty programs, particularly loyalty programs where you want multi-brand extensibility. You want to be able to link, multiple brands and allows them to exchange the loyalty points, right? This is a great use case for integration with things like Sybil, and also more recently, Oracle bought an application called CrowdTwist that's available as our cloud loyalty solution as well, but on premises, typically done with Sybil. Those are some of the examples. Just to summarize, we have sort of this engagement model that I wanted to share with you. We have kind of exploratory stage where we begin with a discovery workshop to look at the use cases and help the customer figure what would be the most beneficial, identify subject matter experts to help define the scope of the POC and minimally viable product later on, and define sort of what are the potential benefits and expected outcomes. Then there is an implementation at the POC level, obviously, that involves spending some time to define the participants, their roles, define the smart contracts and the data and events being tracked on blockchain, integration points, and how we're going to integrate with a variety of these different back office systems or downstream systems, any kind of front end work that has to happen as well. And then basically going from POC into a pilot where you add more organizations, you evaluate the results, complete the kind of MVP, design and build implementation, and then run it as a pilot for a period of time before you actually do a kind of a go live for production. So this is kind of a typical flow. There is more information available on a lot of the stuff. So you can start with oracle.com/blockchain. That's our pillar page. We have, from there, you can link to individual product pages, our on-prem and cloud-based blockchain solutions, a lot of news stories on various customer projects and deployments. We have a very active blog as well at blogs.oracle.com/blockchain. We have a developer site that's being updated, but there is a great developer ebook there, plus a number of other stories and videos from various implementation projects. And then some videos if you want something quick and easy to digest, both on the Oracle video site as well as on YouTube with some customer testimonials and demos and so on. Right. So with that, happy to pause here and take some questions.
Thank you so much, Mark. This is by far one of the most impressive meetups we've had. I mean, it is honestly astonishing and impressive, the work you guys have done at Oracle to build such an amazing ecosystem, really, where you guys have tailored everything to the needs of clients and organizations.
Thanks, appreciate that.
So,
yeah, I mean, we really focus on trying to make, acceptance of blockchain easy in enterprises, right? So, I mean, we've been doing a lot of enterprise work over the years, of course, so we understand a little bit about what it takes. And that was our focus, to enable enterprises to adopt blockchain rapidly.
Yes, and that's what it feels like. And when I went over your documentation and I took a read at your blogs, I really felt that this was specifically for easy use, easy accessibility for clients. And I think that's what makes you guys stand out and make you unique in this domain as a service provider.
Yeah.
So let's take some questions. If anyone would like to write us some questions on the chat, or would like to perhaps unmute yourself to ask questions. I know this was a lot to digest in this very short time. I mean, personally, I would probably require more time in order for me to digest this and really come up with questions. But if anyone would like to ask anything, please feel free.
Yeah, or if you want to share your experiences as well. If you've been working with blockchain in an enterprise context and have some, stories on, your integration efforts and all that in the enterprise.
We haven't, honestly, we haven't gotten that far yet. I mean, here we've done our own POCs, but it was completely from scratch, like on our own, using Hyperledger Fabric. But that never got to to the late stages where we were ready to conduct any sort of integrations. But definitely, it's enterprise integrations is something that we're well aware of. I mean, due to the nature of blockchain being, I would call it the new generation of enterprise application integration methodologies, and this is where our attention was drawn to that and began experimenting and looking in that direction more. And that's what led us to you guys, to Oracle blockchain, and to look at others. I know VMware is also entering this service domain as well. So we're seeing several organizations come into play to provide cloud-based services.
Yeah, VMware, I've seen an announcement, I think last month, a couple months ago. They seem to be entering with their own blockchain technology. It looks like they did not pick up kind of standard, whether it's Hyperledger or some other open source framework, but build something on their own, which is interesting, unusual.
Yes. Jim has a question here, I believe. So Jim, you can go ahead and ask your question.
Sure. Hi, Mark. Thanks for the presentation. It was really good. What I liked about it was very light on blockchain technology and very heavy on integration use cases, which is actually where sort of everything needs to start, because that's where the value comes from, and ultimately the funding for any effort you're going to do on any project starts on that side of the fence. So that was good. I appreciate the link to the blog so I can go read more about it. My background is I've worked in blockchain on Hyperledger for 4 years and built basically an application for automobile registrations in Fabric a couple of years ago, and then have moved on, stayed with Fabric, but also have crossed over and just completed a POC for a state on Indian Aries self-sovereign identity, which, you know, obviously in your slides, none of that gets integrated at this point, but it's just another identity service in effect that could be integrated in the future.
Yeah, we actually have
is on the business side. So I'm coming from it from a guy who ran IT for manufacturing companies and distribution companies, supply chain, all that stuff. And so seeing the fact that you've taken, I'll call it the same basic technology stack and said, ooh, let's focus on making this easy to use with a variety of connectors is the big deal. The only other thing that pops out to me, so that's the sort of the huge value point here, is if I looked at, since I've been doing integration for 30 years, I look at what it takes to integrate. So sometimes it's stepping outside of the Oracle business suites and going in to integrate with other systems. And usually that'll hits on standards. And today it would be based on service APIs, standards from different organizations. And I didn't see much of that in the presentation. So maybe you have more information on that somewhere else.
Yeah, sure. So, you know, a couple comments on some of the things that you mentioned. First of all, just going back to identity management and so on. Yeah, I didn't concentrate much on that in this particular presentation, but we're actually working on some projects around identity management, identity proofing, and so on, leveraging, doing some work with partners around the Indian areas and so on. So it is certainly an area that I think deserves a lot of attention, and we're beginning to see some interest and momentum in that space. And it can be integrated with, you know, the work we've done in Hyperledger Fabric. In terms of the broader integration stories and so on, so we do support in Oracle. You saw the list of adapters, right? There's many non-Oracle systems that we have adapters for, you know, Salesforce, Workday, SAP, you name it. So some of that is done through existing adapter capabilities that is not just focused on Oracle, but many other technologies out there. What we find is that the standards that are out there are not sufficient. You know, there was an effort at one point to try to, if you think about ERP type systems, right, come up with some kind of a standards across them. And there was effort on the OASIS to be able to define, you know, kind of standard building blocks around things like a purchase order, sales order, invoice, etc. Really, you know, Oracle and SAP actually worked on that, but it didn't really result in any kind of widely adopted standards, right? You know, there is a little bit of work that we've seen around GS1 standards base. GS1 provides a metadata schema to define, you know, to define a kind of a product data schema specific to a particular product, and the ways that different properties can be represented, right? And handoffs between the owners, manufacturers, custodians, etc., can be done. So we actually implemented a little bit from another Hyperledger project called Grid. I don't know if you guys are familiar with Grid.
Yes.
Yeah, Cargill, Intel, a couple other companies have been working on that, and they have defined this model. We actually taken a look at that and said, why don't we implement the same thing for Fabric? So we actually prototyped what that would look like in a Fabric context, the Fabric smart contracts on our platform, and done some, you know, POCs with that. So that's one emerging capability, which I think is going to be helpful from the standards perspective. Again, it's very generic, right? It does not say, you know, how do you deal with a, you know, purchase order and the kind of standard events out there. But at least you have a way of defining products. If you're doing supply chain management, maybe, you know, different participants, if they adhere to those GS1 standards, for data exchange might leverage that.
So yeah, listening to what you just said, there's basically application level standardization, things like ANSI 12, order documents and so on, all of that. Like you said with Oasis and what you try to do through Grid, that's one level. The other level is that integrating to standard frameworks like Kafka, stuff like that for messaging to say, well, I have an adapter that you can, if you have something on the other end that's in a sense using Kafka as a publisher or subscriber, we have an adapter that allows you to quickly connect, in a sense, events or transactions, in a sense, onto that kind of a network. And so I didn't see anything about connectivity through, I'll call it standardized, messaging interfaces, stuff like that. I did see, obviously, I'll call it deep set of connections that you provided all through REST, asynchronous REST services, if you will. And the proprietary Oracle connectors, of which you have many. And then to your point, the other thing I did see was connecting to certain specific third-party applications where you already built a proprietary connector. So the example would be, like you said, Salesforce or something. So I did see those. So I think you're strong in those areas. I think there's opportunity to, in a sense, maybe open up to some more standardized integration interfaces as well. But it's certainly—
They actually have an integration.
You've done a ton of work. I think that's a huge win. So when somebody looks at a platform, seeing the fact that it's like I can say, here's Fabric, and put it anywhere you want, do whatever you want. But then I come over here and say, oh, look, depending upon where you're coming from, there's a whole lot of stuff that you may be able to take advantage of that's already done, which is pretty good.
Sure. No, absolutely. And we do have integration architecture, actually. If you want to reach out to me directly, I can send you the link to more of a technical event-driven integration model that uses Kafka, that works with Kafka.
Yeah, that sounds great.
Yeah, I can share with you how some of that works. One of our we have an architecture team that actually wrote a whole kind of blog series in reference architecture, I think like 6 different posts on how to make that happen and how to use kind of more standard messaging and event-driven API integrations.
Perfect. Thanks. Awesome. Sure. So I appreciate it. Thanks a lot.
Appreciate it. Yeah. Anybody else? Any other questions, thoughts?
Thank you, Jim, for that. Any other questions? I believe not.
Hey, Abdullah. Sorry, this is Joy. This is not a question. Hey, Mark. Firstly, that was wonderful. That was quite very comprehensive, very good. Abdullah, we've spoken before, and yes, as you mentioned, yes, the activities in Saudi Arabia are picking up on the blockchain front. We are very happy to work together. I'm from Oracle, colleague of Mark, so I'm sure we can start looking, because we've been, as Mark clearly told, plenty of use cases, various scenarios in how customers are actually looking to leverage blockchain. So I'm happy to reach out to anyone who is interested out there, and we will keep in touch, Abdullah.
Yeah,
thank you, Joe.
I would just mention that we actually have a blockchain platform available locally in our Jeddah data center. You can easily go to cloud.oracle.com, set up an account, and provision one out there in a free trial. So if you want to play with it, very straightforward.
Absolutely.
And if you want to download the on-premise version, Enterprise Edition, there is a link here as well to that page. You can download, and if you have Oracle VirtualBox or VMware environment, you can bring it up.
Certainly. I'll also.
Yeah, sorry.
What I'll do, Mark, is I'll follow up with everyone on here, all the details that you just mentioned, where they can visit these pages to get more information.
Sure.
Sounds great. Well, thank you, Mark, so much. I really appreciate you being with us today. And I personally learned a lot, and I believe there's a lot more learning to do after what you just explained to us today. So
Sure.
I'll definitely be reviewing that content that you're sharing with us.
All right, great. Well, thanks everybody. Appreciate you joining. I know it's getting a little bit late there, but it was great to connect. And feel free to stay in touch if you have any follow-ups. Thanks.
Certainly. Thank you, Mark. Have a great day.
All right. Cheers. Have a great evening. Bye-bye.
Bye.